Hi everyone, my name is João and I will present the paper GitHub Label Embeddings. How to know if a project is open for new contributors. You can use issue labels to infer characteristics from a GitHub repository. Also, you can use the search engine by typing the label name preceded by the label key. GitHub has 9 default issue labels, as can be seen here in the right. Project maintainers can edit, remove, and create new personalized labels. And we found repositories with more than 100 distinct labels. As preliminary analysis, from the 1,000 most popular GitHub repositories, we found more than 13,000 unique labels. As can be seen below, they are very different from the default ones. We also found labels containing icons and language-specific labels. Therefore, the search engine of the GitHub is not flexible enough to identify projects and issues with similar labels. It performs exact label matching and does not avoid a user to spend time guessing similar labels. Therefore, the goal of this paper is to find a semantic representation for GitHub issue labels from which similar or semantically related labels are placed closer. Why not using word embedding models already available in the internet? First, issue labels may be composed by more than one word. Second, open source development context is different from a general corpus, for example, a Wikipedia dump. As methodology, we define the following study steps. We download data from GitHub repository, pre-process label-related information to generate training data, with input for training algorithms, we generate label embedding models, from which we analyze the first results. For this, we define 2 approaches based on the NB and E algorithm, and one based on Word2Vec. Our dataset has more than 600,000 issues from 173 popular repositories. The issues are tagged by more than 1.2 million labels, from which we identified more than 6,000 distinct label IDs, from which we identified more than 6,000 distinct label names. Due to time constraints, I will only present the corpus generation for the Word2Vec approach. For each issue label, we generate 2 sentences. In the first sentence, the label is placed in the first position, followed by the words of the issue title. In the second sentence, in the last position. Each label is handled as a unique token. In the evaluation process, we find the 10 closest labels to each one of the GitHub default labels, and then we invite 5 software engineers to perform qualitative analysis. Each closer label is given a number from 0 to 4, where 0 indicates that the label is not semantically similar to the default corresponding one, and 4 indicates that the label is very similar or even equivalent to the default one. We consider the average score as the effectiveness of each model. Some results. The agreement among the raters is about 0.8. Considering the effectiveness of the models, both NB and E did not perform well, and the Word2Vec achieved the highest effectiveness for most of the 9 default GitHub labels. Finally, I present some interesting examples from the Word2Vec model. In the second column, we can see some writing variations. But in the last column, we can see meaningful semantic relationships. For example, bug with needs reproduction, question with needs more info and support, duplicate with invalid and stale, and good first issue with easy and effort low. As final remarks, we can conclude that the Word2Vec is the most suitable approach, and actually it deserves further investigation. In future work, we can enlarge our dataset, you can implement improvements on the Word2Vec approach, for example, by inserting labels along the title text, and moreover, include the issue body on the corpus. Finally, it's necessary to propose other evaluation methods. Some provoking questions. First, how could be an automatic evaluation for a GitHub label embeddings model? Second, are there other NLP models that could perform better than the Word2Vec for modern GitHub label embeddings? I thank you all for being watching. This is my email, and now I'm open for questions.